Morning, class. Morning. Morning. Hola. Come on, give me that sweet focus. Come on. Come on. This thing is so annoying. Wait for a couple more viewers to show up while I press the autofocus button again and again. Maybe it needs like more lines for reference to improve the sharpness. Come on. Come on. Stupid thing. Whatever. You guys want to see what I made yesterday? Made some ninja stars. Maybe this will help it focus. There we go. I have to say, I also learned how to throw ninja stars yesterday. And they're pretty fun. All right. My tree is not very happy right now. Okay, let's go ahead and get started. So I'm going to start off with the lesson for the IB Physics SL kids. This is going to be really short for the SL kids today. So for IB Physics SL, you're going to have one assignment this week, okay? And that assignment is basically to make a program that will graph a line, okay? And it should label the X and Y axes, and it's going to take in the intercept and the slope of the line, okay, from the user, and then it's going to graph it. So you're going to have to draw a line for the Y-axis, you're going to have to draw a line for the X-axis, and you're going to have to draw a line for whatever line the user wants to see, okay? So let's see how that might work. Okay, so let me go to my desktop. Okay, so we can see I'm in that graphics class, okay? And in the last lesson, we focused on drawing shapes, okay, and just kind of figuring out how it works. But this time we're going to focus on drawing lines. So there is a draw line method. Let's see, where is it? There it is, draw line. And you can see that it takes it draws a line connecting 2 points. So x1, y1, x2, y2 in this graphics coordinate system. All right. So we're just going to be calling g dot draw line. Oops. Okay. So I have the same code that I used on Thursday, and so what did we do? We created a window called graphics practice. We determined the initial size of the window and where it appears. Now, of course, we could use the cursor to resize that window. We said that the program is going to end when the window is closed. We created a JPanel to display something within the window. So the background of the window is white. We added our JPanel into the window, and then we made it visible. Okay, so this code was all code that I gave you. Okay, for this lesson, or for this assignment, you're going to have to add code because you're going to need to get information from the user. Okay. And in fact, you're also going to have to modify the graphic practice with some other methods because you're going to need some fields, for example, that says the slope is this, the intercept is that. So you'll probably need a field for the slope and the intercept, and you'll need some way to set the slope and the intercept, etc. Okay, so you'll need to do some extra stuff this time, not just rewrite the paint component method. But let's just say I have I want to use the draw line method. So I have g dot draw line. Okay. And I want to draw it from 0, 0 to the very center of the window. So the center of the window is going to be at width over 2. Actually, let's just draw it from the center of the window to the opposite corner of the window. Okay. So let's do that. So I'll compile it. So see how it's drawing from 0, 0 to width, comma, height. Okay. So the coordinates of width, comma, height is going to be the opposite corner. So let's compile it. Let's compile this one. Let's run it. So we can see that I've drawn a line, okay, that goes from one corner to the other corner. Now, here's the thing about this, that you can see if I drag around the window, the slope of the line changes, okay? So it's not really a line of a fixed slope. So that's not really very useful, okay, because it just looks however. So why does it look that way? Well, if you see these get width and get height methods, they get the current width of the window. So whatever the width and the height of the window is right now, it is going to, okay, it is going to display, it's going to return the number of pixels in the width and the number of pixels in the height. So that's not very good if you want to draw something that has a fixed slope. So if you want to draw something that has a fixed slope, you probably should do it with just labeling pixels. So maybe I draw the line from 0, 0 to just the line 0, 0 to maybe 500, comma 500. So that would be a line with a slope of 1, okay? Because it goes from, the x and the y coordinates are always the same for this line, okay? So we'll compile it, run it, and we can see that see how, because I've used the pixels, I didn't use that method that gives the number of pixels of the current window size. Because I did the program this way, now the slope of the line is fixed, okay? It only goes so far because I had to have a finite, I could have made the number of pixels where the line ends larger. So really this draws a line segment, okay? And the other thing I want to point out is that this line actually has a slope of -1. Why is that? That's because the so the origin is in the upper left-hand corner of the window, and then the y direction is actually increasing downward, okay? So when you make your graphing program, you're going to have to flip that, okay? So you're going to have to be careful about that, because if I, for example, if the user types in they want to see a line with slope 2, I don't want it to look like an upside down line of slope 2. Okay, I want it to actually display a line of slope 2. So you're going to have to manipulate the slope that the user inputs so that it actually displays a line of slope 2. Okay, so that's pretty much my lesson for the SL students. So, like I said, really quick lesson. Okay. My HL lesson is a little bit more involved. So we are going to learn 2 more sorting algorithms today. Okay. Sorting lists of integers. So there are 2 algorithms. The first one is called selection sort. Okay, selection sort. So let me come up with a list of maybe 5 ints. So maybe I have 15, 7, 8, 1, okay, and then maybe 4, something like that. Okay, so what we do with selection sort is we start off looking at the first one, okay? And what we're trying to do is we're going to go all the way through the list, and we're going to find the index of the minimum element, the smallest element. Okay, so we start here, and so what I would do first is I'm going to have a int temp, which I'm going to start off as 0. So I'm going to assume that 15 is the smallest element in this array, okay? So now I'm going to bring my focus onto the next element in the array, and I'm going to compare it to 15, okay? And so I can see that obviously 7 is less than 15, so now I'm going to set the temp equal to 1, okay? Because now I'm saying 1 has the smallest value, okay? Or the index 1 holds the smallest value in this array. Then I'm going to put my focus on the element 2, and 8 is greater than 7, so I'm not going to change the temp. So temp is still 1. Now I'm going to draw, okay, so now I'm going to draw my attention to the 1, and notice how 1 is smaller than 7, okay? So I should probably have 2 variables, right? I should have the min value, okay? So what is the minimum value up to that point? So here the minimum value is 15, okay? Here the minimum value is 7. Here the minimum value is still 7. But now I know that the minimum value, actually, is 1. So now I'm going to set temp equal to 0, 1, 2, 3. And the minimum value is 1. Okay, so now I bring the my attention to the 4. And 4 is greater than 1, so my minimum value is 1, and it occurs at index 3. Okay, so I've gone all the way through the array, and as I go through, I look for the smallest element, okay? And I store the index and the value of the smallest element. So now, once you've gone through the array once, you move the smallest element to the front of the array, okay? So now we move it to the front. Okay, so now I'm going to swap the 1 with the one that was at the front of the array. So now I have 1, 7, 8, 15, 4. So you see how I did that? I swapped. So we go through the array, we find the smallest element, and then we move it to the front. Okay? Now, what we're going to do is we're going to go through the array again. This time, not starting at the first element, or at the 0 element, but starting at the element 1, like that, okay? Because we already know we don't have to start at element 0 again, because I already know that I put the smallest element of the list in the front. So now I'm going to find the second smallest, okay? So I can see, so again, I'll let temp equal 1, and I'll just move my attention along the list. Like that. Well, 8 is greater than 7, so my temp is still 1. Move my attention along. 15 is greater than 7, so my temp is still 1. Move my attention along. And I say, whoa, 4 is less than 7, so my temp is now going to be equal to 4. Okay? Now, so that means I've gone through the list a second time. Okay? Gone through the list a second time. So now, every time you go through the list, you move the minimum 1 into its spot. Okay? So now I'm going to swap the 4 with the 7. So I have, so we have our swap. So now I have 1, 4, 8, 15, 7. Okay? So that was my second sweep through the array. All right. So now I'm going to go through again only this time, so I'll call this pass 1. This is pass 2. Okay, so now let's do pass 3. So our array is 1, 4, 8, 15, 7. And now in pass 3, I start my focus not on 1 or 4 because those have already been sorted into place. So now I go to the next one and I start there. So now I have temp equals 2. Okay. And I put my attention on 15. 15 is greater than 8. So my temp is still 2. Then I put my attention on the last element. Okay. And 7 is less than 8. So my temp is now 4. And I've gone all the way through the array a third time. So now what I'm going to do is I'm going to move this one to the front of the unsorted part. Okay, so I have 1, 4, 7, 15, 8, like that. So I did my swap. Okay. So now I start pass 4. Pass 4, my attention is going to go to this element first. Okay. And so my temp is 3. Then I focus my attention on 8. 8 is less than 15, so now my temp is 4. Okay, and I move it to the front of the unsorted part, so I swap it with 15. So 1, 4, 7, 8, 15. Okay, so this sorting method, it has basically 2 phases. You pass through the list, pass through the array, find the smallest one. Once you get to the end, you take the smallest one you found and you move it to the front. Okay? And you keep doing that. Now, how many passes through do you need to do in order to make sure that you, well, we can see that this was an array of length 5, and we had to do 4 passes. So in general, if you have an array of length n, you have to do n-1 passes through it in order to get it fully sorted. The first pass is the longest because you had to go all the way. For pass 2, I only had to go from element 1 to 4. You get what I'm saying? So it gets faster as it progresses along. But still, this is not a very efficient sorting algorithm. I guess the IB doesn't have, I was looking at the IB curriculum and they don't really have any of the efficient sorting algorithms. They only have like the worst sorting algorithms. So I think they're just trying to introduce you to the idea of sorting. Okay, so that is called selection sort. Oh, and I wanted to say one huge disadvantage of selection sort is that it doesn't know when it is fully sorted. So like what if I had an array that was already sorted and I ran selection sort on it? Okay? I would still have to do all these passes through in order to check that it's sorted. Okay? So there's nothing in selection sort that would like test if it is fully sorted and then just break out of the method. You get what I'm saying? So that makes it really not so great. So there's another algorithm, which is the second one we're going to learn today, which sort of solves that problem. and it's called bubble sort. Okay. I'm going to use the same array, 15, 7, 8, 1, 4. Okay. So again, a lot of these sorting algorithms, they do passes, just repeated passes through the list. Okay. So the way bubble sort works is we compare two. Okay. And we swap them if they're out of order. Okay. So I swapped 15 with 7 because 15 was greater than 7. Now I compare these two. Okay. So, and I can see 15 is greater than 8. Now I compare these two. So see how I'm comparing the two that are next to each other, and I go down the list. 15 is greater than 1. So I swap them. And then I compare the last two. And 15 is greater than 4, so I swap them. Okay, so this was kind of like pass 1 through the array. All right. Now, the reason it's called bubble sort is if you think about bubbles in a swimming pool, the bubbles kind of go up to the top to the surface, right? If we look at this 15, see how the 15 pretty much just got moved right to the end of the list. Okay, so it's a lot like a bubble rising to the surface. So that's why it's called bubble sort. Okay, and so you just repeatedly pass through the list. Okay, so I compare 7 and 8. That's in order, so I don't have to do a swap. Okay, so I have 7, 8, 1, 4, 15. Then I compare 8 and 1. 1 is less than 8, so now I have to swap those. Now I'm comparing 8 and 4. Those are out of order, so I swap them. Now I compare 8 and 15. That's in order, so no swap is required. Okay, so that was pass 2. So now I pass through again. I have 7, 1, 4, 8, 15. Compare those two. It's out of order. So I got to put them in order. Now I compare the next two. Out of order. So I swap them. Compare the next two. That's in order, so I don't swap them. Compare the next two. That's in order, so I don't swap them. Okay? So that's pass 3. Now, I can see right now that they're sorted, but how does the bubble sort algorithm know when the array has been sorted? Well, it knows it's been sorted when it does a complete pass and no swaps are required, okay? Because see how right here I had to swap. So I know that this was like almost in order, but in the third pass, I still had to do a swap, okay? So what you have to do is you just keep running the bubble sort until you do a pass where there was no swap, okay? So in the bubble sort, it's useful to have like a Boolean variable that is set to false at first, and then, or I should say, just a Boolean variable which holds whether there was a swap that occurred or not, and you just keep running the algorithm until at the end of the pass you have no swaps occurred. Okay, so we got to go through one more time. So I have 1, 4, 7, 8, 15. So I compare these two. That's in order. 1, 4, 7, 8, 15. Compare these two. That's in order. 1, 4, 7, 8, 15. Compare these two. That's in order. 1, 4, 7, 8, 15. Compare these two. That's in order. So I pass 4 with no swap. So that means I did it. It's sorted. Okay, so notice how this, if we did the selection sort, the selection sort has to go all the way through n-1 times every single time, even if the array is already sorted. So it has to do a bunch of passes. So selection sort, really slow. Okay, bubble sort, on the other hand, if the array started in order, you would do one pass through, and you would detect that no swaps had occurred. Okay, you would detect that no swaps had occurred, and on that very first pass through, so you would know that it was sorted, and then you would break out of the sorting algorithm. Okay, so it gives you an escape button if the array is already sorted. So that's nice. Okay, so I think for today's lesson you're going to implement one of these. I want to say it's bubble sort, and I can't remember, but you're going to implement one of them. All right, so that's my lesson for today, and I will see you in the Zoom room.